Part 3, EOC review. Here you go, Dragons. Solve the following equation for x. Here we go. We are going to distribute. So if you notice, I multiply a negative 3 times x and a negative 3 times a positive 1 to get this. The next thing I'm going to do is combine like terms that are on the same side. So a negative 3 plus 7 is 4. Now I'm going to move the variables to one side, so I'm going to make a 0 pair out of this. Remember, if it's minus on the right side of the equation, it's going to be plus on the other. So if I combine that, a negative 3x plus 5x is 2x. Still have the plus 4. That's a 0, but I still have a negative 11. So now I'll make a 0 pair with this because it does not have a variable. And so now I get this answer right here, because a negative 11 minus 4 is a negative 15. And I'll divide by the coefficient, and I get my answer of negative 7.5. Now, one thing that you could do in this problem as well, you can check, go back and plug this everywhere that you see in the original problem. If you plug in a negative 7.5 here and a negative 7.5 here, you're going to see that it works. Calculator will make quick work of this. If I type in a negative 3 parentheses, but instead of an x, I'm going to type in my answer, negative 7.5. See if I can get a little better action happening here. And then I'm going to do a plus 1, close the parentheses, plus 7. Why did I do that? Let's try again. Negative 3, negative 7.5, plus 1. Plus 7, okay, so that gives me 26. Now let's do the other side of the equation. Negative 11 minus 5 times my answer, which was negative 7.5. You notice we get the same thing. All right, the next one, if we look at the perimeter of a rectangle, the first thing that we need to do is make sure that we have that. We need 2 lengths plus 2 widths. So right away as we look at our answer, just by looking at the perimeter of the rectangle, we know this one is not going to work. This one just has a single length plus a single width, and I need 2 of them according to my formula. So we read the second one. The width, which I'll call W, is equal to 2 feet less than twice the length. Well, twice the length is 2L. Less than, in this particular case, means minus, and I'll put 2 over here. Anytime you see the phrase less than, you have to switch the order. It's not the order in which you read it. 2 will go behind the minus sign, and twice the length will go in front of that. So now I'm just looking for that answer. Let's see, a width is equal to 2L minus, you can see that's this guy right here. The answer is D. Over here, what is the range? So we're looking for what? X's or Y's? We're looking for the Y's. And we notice that all of the Y values are in quadrants 1 and 2. Well, in quadrants 1 and 2, all the Y's are positives. The question really just becomes, first of all, we shouldn't choose anything with X because that's domain. All real numbers include negatives, and my graph does not come down here for negative values of Y, so that one is gone as well. The question is, does this actually touch 0 or not? Because that's the only difference between our answers. Well, even though the picture looks like it's going to come down and rest on this, if this is exponential, it will just simply get closer and closer and closer and closer to 0. It will not touch it. Problem number 20, which statement actually describes? Well, let's go ahead and find some things from this graph. This one has a y-intercept of 6, an x-intercept of -2, and let's see what our slope is. If I make a slope triangle from that -2 up to the 6, my rise is 6 and my run is 2, so my slope is going to be 3. So as I'm looking at this particular problem, it says which one accurately describes it. The function has a slope of 3 and a 0 at 6. A 0 is a x-intercept. Well, that's not true. Sorry. Function has a slope of 3 and a 0 and -2. Okay, that one appears to be true. Let's just go ahead and make sure that we double check, see if they're not trying to slide one past us. Function has an x-intercept at 0, 6. No, that's on the y-axis, not an x-axis. The function does not have any 0. Sure it does. It crosses the x-axis. It has a 0. It has one of them, so B is what we want. Okay? Alright, so if you're watching this video right now, I want you to take your pencil and make a big O X, and I want you to put it over page 13. Do that for me, please. Alright, next one right here. Which equation models the amount of money needs to spend? 1 cup of coffee for $2.50. That's a one-time fee. One-time fee of $2.50 for a cup of coffee. So I need my $2.50 to not be multiplied by a variable. So that's either this guy right here or this guy right here. This one, these two mean that I'm going to have multiple cups of coffee because it's multiplied by the variable x. So because I'm only having 1 cup of coffee for $2.50, A and B go away. So now I need many cookies. That means that $1.25 is multiplied for each cookie x. So I need 125 to be multiplied by x. Now we have that right here. So we want the sum. You remember what sum means? Sum is addition. So we want answer C on this one. Over here, which linear equation has the same y-intercept? So we're looking at the y-intercept of 4 by simple observation, and my slope is going to be 4 over 6, which is 2/3. So actually that's not positive, that's a -4. What am I thinking? I'm glad you stopped me, because that's -4. So what I need to do is come down here and solve and see which one of these will give me a y-intercept of -4. So if I take this guy right here, move the 2x to the other side, it's positive in the original problem, so that means if it goes to the other side it's negative. And if I divide by +3, look what I get right there. What's that equal to? That's equal to this guy right here. So we want answer A. Okay. So in this one we're going to find the solution to the system. So what I'm going to do is take this first equation and I'm going to solve it for y. So if I move the 3x to the other side, it becomes a positive 3x divided by the coefficient. So if I clean all this stuff, I really have this equation right here. So the question becomes, do I have no solution? Well, no solution means the lines are parallel and they have to have the same slope. These two slopes are not the same. Okay? Slope 1 is 3 over 2, slope 2 is 2 over 3. So they can't be parallel. And if they're going to have infinite solutions, that means they have to have the same, they're the same line. Well, these obviously are not the same line. So it's going to be one of these two right here. And so if we take our calculator and we plug these equations in our calculator, or if we just try them, we're going to find out that B is our answer. Go ahead and plug these two equations right here into your calculator, go to your table, and you're going to see that that's the one that we want. All right, last one for today. All right, so we have ear infections, bacteria. We have this as our starting amount. So we start with this. So in our exponential equation, remember y is equal to a, which is our starting amount. And in this particular case, penicillin is killing. We're making the bacteria go down. So this is going to be a decrease. So it's going to be 1 minus my rate of decrease over time. All right? Oh, I already had it written down. I don't know why I did that. So we need something that has a starting amount right here of 50,000. All right, so right away we can see that these two guys are the only ones that have 50,000 in them. So because that's not 50,000 and that's not 50,000, A and D go away. And here we go. Are we going to use that? Or are we going to use, because we have that as an answer, right? But look, if I take my 1 minus R, all right, and I actually put in a 0.07 there, because that they tell me the rate is right here every hour, look what I get. I get a base of 0.93. And that's what I want, this one right here. So the correct answer is C. Most everybody picked B. And again, notice what they do. They give you that number, they put it as an answer choice, and they place it directly in front of the correct answer. So you need to be thinking about growth or decay before you answer that. So we're going to end on a happy note. That's our star problem of the day. Please draw a nice big star by page 15. Until next time.